So I want to look at transformation, and like I mentioned, transformation, it is in 3 parts. The first transformation, which we call as isometrics of what we call. So today I'm going to look at just transformations. Okay, so I've got transformation number 1 of what we call isometric transformations. Okay, transformations. And we also have what we call isometrics. Isometric transformations. Okay, transformations, very simple. It's very simple. So usually in paper 1 they bring isometric transformation. So by isometric we mean those transformations whose, we can simply say these are transformations whose shapes, sizes, okay, shapes and sizes do not change. The keyword here is change. Okay, so the shape, the size of that particular object will not change under isometric transformation, as simple as that. It will not change. But when you talk about none, just the opposite of this one. So none, these are basically the transformations, okay, whose objects, shapes, so I'm simply talking about the shapes, the sizes do change. Okay, yeah. So then under isometric transformation, that's what we are actually concentrating on for today. We're going to look at the isometric transformations, and these are as follows. So we have got translations. We also have got rotations. We also have got a reflection. Okay, so these are the 3 common isometric transformations. You've got translations, rotations, and reflection. Okay, well, then if we look at the non-isometric ones, we can talk about the enlargement transformations. Number 2, we have the stretch transformation. We also have the number 3, the shear transformations. And of course, once these are taught, we'll look at what we call combined transformations now. So basically, we have got 2 sets of transformations. 3 for isometric transformations whose shape, sizes actually do not change. Okay, and under this we have the translations, the rotation, the reflection. You see that they just translate, okay, they just rotate, they just reflect without actually changing their sizes or their shapes. So those, they fall under isometric transformations. So these 2 here, they summarize the transformation topic. Very easy. Okay, so now looking at that question there, we see that we're talking about translation there. We are basically talking about the translation. So under translation, I just want you to write just a few things on translation. Okay, I just want you to look at just a few things. I want you from here to be able to answer any question to do with translation from here. That's what I want you to do. Well, translation vector, under translation, we have what we call, we say a translation vector denoted denoted by t, x, y, where x is the horizontal movement either left or right, and where y is the vertical movement either upwards or downwards direction. Okay, direction. Okay, very, very important. This is the weapon that we use actually under translation. So a translation vector denoted by t, x, y. Okay, so this one is written in column. Okay, this is what we call translation column vector, so to speak, which is t, x, y. So this is the one that translates objects, onto their images, basically. You get it? So this will translate the object onto its image. So this is the weapon. So this one, like I said, is defined by saying we have got the x and the y, where x is simply the horizontal movement, either left or right direction. Okay, you may even include direction here, please. You may even include direction here. You may include direction. And where y is the vertical movement, either upwards or downwards direction. What are we talking about? What are we talking about? Okay, so for example, if we have a Cartesian plane here, if you have got a point on the Cartesian plane, if I've got a point on the Cartesian plane, okay, say we have, if you have got a point, say we have got a point on the Cartesian plane, okay, say this is our Cartesian plane here. This is x-axis and this is y-axis. I just want you to pay attention. Just look at the board and later on you'll be able to write. Say we have got this point. Say we have got this particular point. Say we have it right here. This is the point here. Say this is this point is 2, -4. Okay, 2, -4. This is the point here. Okay, this is the object point, the objective point. Okay, so now, what are we talking about here? Of course, before I give you the formula, okay, so now, you want to, this point is translated, okay, this point is translated by the translation vector. Let's say, if you're given the translation vector, say this point is point A, roughly put, let's say this is point A. The 2, -4 is point A, which is being translated by the translation vector. You want to go to its image. Its image, we can denote it as A prime. You get it? Just to differentiate it there. So what are we talking about? Say we have got the translation vector. If you're given the translation vector, say the translation vector here is 3, 2. Okay? 3 and what? And 2, so to speak. Okay? So you're asked to say, could you please write what will be the image of object A, of point A, given that it is being translated by this translation vector. So using this definition I've written here about the column vector, okay, or the translation vector, what you're talking about here is that we are going to move horizontally, okay? How many steps? Which side? To the positive or to the negative? Exactly to the right side, isn't it? So here you are going to move 3 steps to the positive direction of x-axis, 3 steps. So we're going to move 3 steps. Roughly say, for example, if we had, let's say maybe in terms of the scale, this is 0 here, and this is 2, of course, as we're able to see, this is a 2. Okay, say this is a 3 here, okay, and this is a 4 here, and say this is a 5 here. Okay, that's why it's usually done on a grid. It's quite easy for you guys on a grid, but it's all right. It's okay even this way. It's okay. So now we're going to move, 3 steps, okay, horizontally to the positive side, okay, to the positive direction. So we're going to move 1, you see, 2, you get, 3, you get. Okay, we pause here. Do we end here? No, we don't end here. We are done with the x movement, isn't it? Okay, to the positive. So this directs you. So the translation effect, in other words, it has got it has got the direction. The directions are basically the sign. Okay, what state is this? Is this number 3 here? It is a positive, isn't it? Meaning to the positive. Horizontally, you need to move to the positive direction of x-axis. How many steps? 3 steps. From there, you move vertically. Where is it? Upward or downward? Upward. It is upward because it's the positive, x values. So there, we're going to move 1, 2, 3. That's to the positive side of the x-axis. There, 3 steps. After which, you move how many steps further? Sorry, 2 steps upwards, isn't it? Okay, roughly say if we had, since we said this is -4, say this is -4 here, this would be -3, this would be -2, okay, this way. So what you're going to do is that after reaching here, you're going to move 2 steps upwards. So this could be, 1 step here, and of course the last point here, you get it? Okay, so this is our destination, you get. This will be our destination. Okay, this will be our destination here. So we've moved 1, 2, 3. Okay, 3 steps. Where? To the positive side of x-axis. After which we move, to the positive, side of the y-axis vertically. How many steps? 2. That's the 2 there. We moved 1, 2 there. And this will be our point. This will be the object point, so to speak. And this will be A prime, or the image of this particular point here. But you can even write to say, okay, this would be 5, -2. You get it? And this would be the image of this particular point here. You get? You see? That's what you do, my boy. That's exactly what you do. And this is quite intriguing, quite very true. So, if you don't want to use this method, I'll give you 2 methods. The other one is for the formula. You simply come up with a formula. What formula is it? What formula do we have? So the formula is very, very simple. If I go to the formula, I'll say the translation vector, like I said, it consists of x and y, remember, values. And take note, that's for emphasis. If I can try to continue. All right. So, look, just for emphasis sake, okay, remember, this x and y, these are simply, movements, horizontally to the positive or to the negative, meaning this x here can be negative or positive. Take note, I want you to pay attention to this one. Very, very easy, very simple, very simple. So this translation vector t, okay, the x can be negative or positive. Take note. Equally, the y can be negative or positive. Take note, please. Okay, these are basically the movement, except we all start with x and the horizontal movement, after which we move to the vertical movement. Okay, vertical movements either upwards or downwards. When you talk about upwards, we're talking about the positive positive direction. When talking about downwards, we are basically talking about what? Negative direction. Please take note of that one. Take note of that one. Equally, that the same applies to this one. When talking about left, we're basically talking about to the negative direction. Okay, horizontally, meaning we're going to the negative side of the x-axis. So when talking about the right side, that's basically the positive side over the x-axis. Okay, and the same is true with this one. Upwards, that will be positive. Downwards, that will be actually negative there. As simple as that. And remember, the movements are totally based on how the translation vector is. You just check. For example, as we're able to see here, to say we're just moving horizontally to the positive side and vertically to the upward side, isn't it? Okay, so that's what you do. Now, how else can we write this one instead of you going there, but it's important to understand the basics. Okay, just look at the translation vector there. So this translation vector will move this one, okay, this way. So it will translate this particular object onto its image, okay, by the way of actually analyzing that one. Now, what if you don't want to use this method here and you'd want to use the formula? So I've got a formula here. I want you to appreciate the formula. So the formula that we have is as follows. You write the translation vector here, take note. This is the translation vector, like I said, it can be negative or positive x, okay, equally negative or positive y. Okay, so it's a translation vector, this is the translation vector plus the object in consideration. The object. So here, let's say the object, maybe it's A, roughly put. Let's say this is our A, which is the object. Equally, it is written in a column. Okay, as a column vector, say we write it as it is here. This is a 2, and this is a what? A negative 4. Okay, or maybe before I apply this one, let me just write the general one. Okay, let me just write the general one. I will use P instead. So for the object, I will use check note. So this is the translation. I'll say this is the translation vector, check note, denoted by T. Okay, then here you've got we'll say plus. You're going to say plus. Okay, the object, check note please, the object. This will give us what we call the image of this object. Check note please, check note. Okay, so this is basically the standard, and this is what I'm trying to write here. So take note. So the translation vector txy, check note, plus the object. Say let's put P just to denote an object. Okay, so put T here, P here. Then the object, equally you can put X, Y here. Okay, something like this. This will give us the object, the image of this P here. So you can denote the image of this particular object here as P prime. P to the power in this hyphen. I don't know how you call this one. Apostrophe. What do you call this? Apostrophe. Exactly. So this is the image here. So I'm going to say this will be X and Y. So this is the notation. This is the formula for any translation. This is the formula for any translation. First, you write the translation vector here, then plus the object, and that the two will give you the image there. As simple as that one. For example, let's see the authenticity of this particular formula. So in this case, we're given if at all we are to, let's see if at all we get this here. Okay, the translation vector there is given as T. That's a positive 3. Positive 2. Okay, let's try just to plug in there and just try to appreciate what we can have here. Okay, this is the T here. Then say plus. Okay, we're going to say plus. We'll write the what? The object, isn't it? Yes. Let's write the object there, which is 2, negative 4. Okay, this will give us the image of A. Okay, now we do not know the image. We want to see if at all we get this. Let's see. If you say 3 plus 2, what do you get? 5. That's 5. If you say 2 plus negative 4, what do you get? Negative 2. Very true. A prime is 5, negative 2, which is true. You get it, huh? So you can either use this one or this one, but I want you to know both. At all costs, you just have to know both. So the first thing that you write is the translation vector. If it's not given, then the question will be maneuvered in one way or the other. So with this particular information, You can do anything. You can do anything, my boy. For example, apart from this one, I don't know if you can copy. Maybe you copy first so that we look at another figure now. We see what we can do if we translate that one. Because I want you to do that same question yourself. Yeah, I'll give you that one as actually the exercise. Yeah, I want you to do that one as the exercise. Okay, so just try to copy so that we see how this goes. Okay, just try to copy. Let's see how this goes. Okay. So much is like that now. You're done? Great, thank you. So now let's look at another problem. For example, now, okay, what it is from the same formula here, Sunny, from just the same formula here, what you do is this. They just maneuver. At times, the image will be given. You get it? The translation vector will be given. Say the object is not given here. You get? So they give you such a scenario. They give you such instances. Okay? So say this, we don't know, this is x simply and this is y. But we are given it's what is translation vector. So this translation vector, okay, it is translating this object onto its image. So the image of the object is given and the translation vector is given, but the object is not given. What do you do? How do you find the object? Very easy. So for that one, you simply use the formula. The same formula here, you apply the formula there. How? So what you do here is this. Look, want to find this? Very easy. You simply, okay, make this the subject of what? Formula, as simple as that. And of course, T here simply denotes, just telling you to say this, vector is actually, the translation vector, the one that is doing the job. So if you want, sometimes you may write T there, but it's okay, even with or without, so that you don't get confused. Okay, so from there you say, okay, if I make this the subject of formula, I'm going to have this side. I will have this object xy, okay, being equal to. We are shifting this the other side, isn't it? Don't worry, this is not a negative. It's just the board. Yeah, so I'm going to shift this translation vector the other side. What is going to happen? It will be negative, isn't it? Okay, now observe. We said this is the A, the object being equal to. This is the image. We're going to write the image anyway. I can even write, A prime, that is 5, negative 2. This hasn't moved. So we bring this guy the other side, this will be simply negative. That should be 3, that should be 2. You get? Okay, take note. the elements inside, or the entries inside, they do not change their signs. Okay, so this is considered as one whole thing. The whole lot of this is just considered as one whole thing. Don't concentrate on the inside entries, no. So its operation will be actually outside here. If it moves, what changes is simply the outside operation, not inside, no. You get it? So when you take it the other side, what will change is the outside part. And this is it, what you are seeing here. Once that is done, you do the needful here. We're going to say the object xy, okay, xy, this will be, you subtract the corresponding elements. 5 take away 3, that will be 2, okay, great. That will be 2, negative 2 minus 2. Oh, great, that's great, that's so wonderful. And this will be actually the object. And if you can appreciate, you see for sure to say indeed, this is it. So, this is 2 against negative 4, very true. Using the formula. Very, very easy, my boy. We don't want you to forget this. It's a weapon for you. Okay? Remember, take note, this doesn't only work on points. It can even work on objects. You get it? So for example, and that's exactly what, that's another interesting part that I want us to look at. That's another interesting part that I want us to look at. Say for example, if we have, say we have this particular figure. I'll just draw it here. Okay, I'll draw it like this. However the shape is, and I'll give the coordinates of my own choice. I'll say maybe this is a 2, this is 2, say this is 2, say 1, this particular point here. Say maybe this is this is you can say okay, this is B, A, D, C. You get, we have this here, and this is say this is maybe 5, 1 as well. Okay, then this one, say this is 3, this D is 3, maybe 6, roughly put. Okay, we have such. So once again, you're being asked to say what will be the image of this particular triangle. The question comes now and asks you to say, can you find the image of triangle BDC? Okay? Okay? So we know here to say triangle BDC, okay, has got vertices B, it has got 2, negative 1, D, it has got vertex 3, 6, C, it has got vertex 5, 1. What will be the image of this? Okay, so you may be asked to say, you may be asked here to say, you will be asked here to say, find the image, okay, or they'll simply say, find, they write like this, the image of triangle B prime or B1, we get D1, C1 to denote the image of this object. What are you supposed to do? You simply apply the same concept as me, except here you'll be going one by one. You get it? Okay, remember, you'll be given the translation, say we use the same translation vector here. Okay, so I'm going to move this object by this translation vector onto its image. How? By doing exactly what I said. For example, if you, like I said, I gave you 2 methods. The one that you can use just by moving, moving the point. Say, if you are to move B, we need to move, looking at the translation vector there, we'll move horizontally to the positive x-axis. How many steps? 3. You move this 1, 3, 1, 2, 3. When you get there, you check again to the y-axis, upwards, of course, that's positive there. How many steps? 2. So it'll be 1, 2. You get, yeah? So you end your point maybe somewhere here. That will be B prime here. You get, yeah? That's the idea. But anyway, you can do that one. Like I said, it's a choice. And like I said, it's usually such questions they come in paper 1 where I've got a grid. You get, yeah? A grid, and it's easy to, of course, follow along. But if you don't want, just apply the same concept there. Given the translation vector and the object, it's easy to compute, the image. So if you want, you can just say, okay, if you have to add these two guys here, this and this one, this is the translation here, you add to this one. What will be B prime? For example, if you're asked to find the coordinates of B prime, D prime, and C prime, say what will be B prime?
5,2.
Exactly. Yeah, that's going to be 5, comma what?
3.
Very good. Exactly. As simple as that sounds. Provided you don't swap this. The translation vector and the object are added. When they're added, they'll produce the image of the object. Take note. Never swap. If you swap, it will be a challenge. Yeah. So that's how operations will be. So as simple as that. And you need to be very mindful for the question. If the question says the coordinates, they don't mean the column vectors. You write it as a coordinate x, y. So that will be 5, 3. That's very good. Okay, let's see. D prime. What would be D1?
6, 8.
Exactly. That's going to be 6, 8. Exactly. Wow. What would be C1? What would be C1?
8, 3.
You check nicely. Okay, see that to 5 plus 3, that's 8.
3.
3. As simple as that. And that's the answer there. I'm sure from here you'll be able to answer those with the less problems. You get it? Yeah? I know for sure. I know for sure you will be able to answer that one. Very easy. Then the other thing that is worth note apart from this is just the last part where you are asked to say to describe a translation. To describe. Now it's about writing, in word. In word. So I just want you to write something here. Of course, let me just write it here, then I'll give you time to copy. So what you need to do, just the last component apart from this one here. Here you've learned, and I can assure you, what I've given you here is enough on translation. Very enough. I've given you actually 2 methods which you can apply if you want to use the movement today based on the translation vector, or you simply use the formula. But I want you to know both, please. Okay, now let's look at the last part. The last part on translations is whereby we make what we call the description of the translation. So how do you describe? How do we describe? So describing a translation. Okay, fully. Fully. So a translation will be fully described if, number 1, you give, I'll say name it. Okay, say give its translation column vector, okay, denoted by T. Okay, number 2. Number 2, give its translation vector. Then number 2. Basically, this one will be fully described if you give its translation vector and indeed its name to say this is give its name. Give its name as well. You get it? To say the translation, that is to say, i.e. translation. This is the translation. You get that? Okay, so these are 2 things here. So all you need to know is the translation will be fully described if, number 1, you give its translation vector. It's a weapon, one that's always there. Give it. Then number 2, give its name. What type of transformation is it? Oh, it's a transformation. So you can say, it's a translation. So you can say, when you're describing such a figure there, just after analyzing, at times they won't tell you to say this is translation from transformation. No. They won't say this is the translation for a transformation. No. They'll simply give you such figures like this, then they'll tell you to say, can you describe it fully, this particular arrangement, this particular transformation? What is this? So number 1, you can say, okay, it's a translation with a translation vector, waremba. You get it? So that would be T, whatever X, Y there to maneuver. You can pick maybe just one point there to just come up with the translation vector there. You just pick the object, you get, you know, you pick maybe the object and the image. Say maybe the object and the image are given. For you to get the translation vector, you know how to maneuver. You make the from the formula, you make the translation vector be the subject of what? Formula. Remember, you want to find the translation vector here, where you simply shift the object to the other side, and it will be negated here. Then you do the need for the you subtract the corresponding elements there. Then you find the T vector, so to speak, the translation vector, and that will be the translation vector there to put there. You get. Once that is done, then you'll be able to you'll have the courage to actually describe in words. So you say, okay, it's a translation with a translation. It's a translation, a transformation with a translation vector, whatever. You get, and that will be it all. Unless you have further questions on this. Otherwise, what I've taught you summarizes the translation. Nothing more. Yeah. So now, attempt those two questions. Then I'll mark you. Okay. Thank you so much. Please subscribe to my channel. Like my videos. Okay. Thank you so much. See you in my next video.